Hello, friendly alumni. Welcome back to From Here Forward, a UBC Podcast Network podcast. I'm Carol.
And I'm Jeevan.
Okay, are you ready for this? Jeevan, do you ever feel like a plastic bag drifting through the wind? And then I don't know what Katy Perry says, but do you catch my drift? Do you know where we're going with this?
This is a missed opportunity to say drifting through space.
You said it.
That was awful. But we're going to roll with it. What a lovely introduction to today's episode. Today, we chatted with Aaron Boley, an astrophysicist and co-director of the Outer Space Institute, a network of world-leading experts that addresses challenges related to space exploration.
His research is particularly interested in the implication of excess objects in space and their unprecedented impacts on the atmosphere. Yeah, excess objects in space.
Another thing we didn't know we had to be afraid about. But our conversation was really informative, and there's still a lot of hope to be had with the future of space. There are ways that we can all take part, and Aaron was the best person to talk to about the subject. So without further ado, let's dive in.
Let's rock it.
I like that one.
My name's Aaron Boley. I am an associate professor in physics and astronomy. I've been increasingly more concerned and interested in studying space sustainability. And so, in that vein, I have been working on issues such as reentries, pollution to the upper atmosphere, orbital debris, and a number of other issues related to things such as using the moon, using other places in outer space. And as part of that, I co direct the Outer Space Institute, which is a network of researchers who are all united with their commitment to address grand challenges in humanity's use and exploration of outer space. And I co direct that with a friend and colleague, Michael Byers, who's an international lawyer.
Awesome. Thank you so much. So I guess we'll jump into talking about space junk a little bit. You were recently a co-author on a study with fairly alarming conclusions about the risks of falling space junk. But to start, can you tell us a bit about what space junk actually is and how often it's making its way down to Earth?
So, from the start of humanity's use of outer space, there have been multiple components that get placed into outer space whenever you want to put something such as a payload into orbit. That might be part of a rocket body that gets left in orbit. Currently, there are over 2,200 abandoned rocket bodies just left in orbit right now. So, these are basically school buses that are uncontrolled, just orbiting the Earth. There are bits of junk that just get released. This could be pieces from just the mechanisms themselves. And once you have things that are left in orbit, then you can also have collisions. And those collisions can be with other pieces of space junk. They could be with meteoroids. They can be with active objects. There's been one satellite collision. One of the satellites was defunct, one of them was active, and that happened in 2009. So there are a number of ways in which unwanted material gets placed into orbit. Even if it's just a satellite has reached the end of its lifetime and it's abandoned in orbit.
Sounds a little concerning. Are there any places specifically where this has been proven to be a larger issue? How likely is it that someone's just walking around and then, they get hit by this abandoned school bus of a space junk?
Luckily, we have an atmosphere that protects us from meteoroids, small asteroids is one way, and also from re-entering space junk. Every day there's something that's re-entering more or less, and it's usually not a major concern. However, large objects coming in can be of considerable concern, and the cumulative effects of all the material coming in also becomes a concern. So, to the question of what about individual risks? You walking around, should you be concerned about getting hit by space junk? The answer is no. You, as an individual, should not be concerned about being hit by space junk. There is still a growing possibility of you being affected by space junk. And that could be from a diverted flight or a delay, or it could be from damage to infrastructure in the area. So these are risks that are increasing. And when something re enters, there have been two pervasive beliefs that have led to this practice of abandoning things in orbit. And that practice has been that one, the Earth is really big. And so kind of you could just ignore that things are dropping out of the sky. Another belief is that, well, the atmosphere takes care of most of the material anyway. Really large objects, in particular, things like these rocket bodies or really big satellites, really only, you know, 60% or so actually ablates in the atmosphere. So there's actually a considerable amount that can make its way down and hit the Earth. There are large objects that are embedded in some of these bodies that can survive reentry, even if most of the material does ablate. And so, an example of that are pressure vessels that are often used in these rocket bodies for multiple purposes, cryogenics, and many other things. And some of these are meant to withstand extreme pressures and so forth, and they do survive. And so, there have been these pressure vessels from Falcon 9 rockets that have been found across the world from reentries. And so this is something that actually comes down and it has caused damage already. One of the big, really to put it into scale for those listening is that, if we're looking at what's on orbit and we have somewhere around 15,000 satellites in orbit right now. Only around, let's say about 11,000 to 12,000 are active satellites. About half of them, a little, actually more than half, are controlled by a single company, and that's SpaceX. The majority of the satellites at this time are now in low Earth orbit, so that's up to about 2,000 kilometers away from Earth. So those are just the numbers of the satellites. And I already mentioned the rocket bodies. They're about these, 2,000 school buses or so. But if you go to this debris, and there's debris that's about 10 centimeters or larger. If you go to those sizes, then there's somewhere around 30,000 pieces of debris on orbit that's uncontrolled, moving around very quickly. If an object gets hit by something that's about 10 centimeters in size, the typical orbital speeds, then that causes a catastrophic disruption of the object it hits. It blows it to pieces. If you go down to about a centimeter in size, now you have 1,000,000 pieces of debris on orbit. And these are the types of sizes that can cause damage. It won't cause catastrophic disruption necessarily, but can cause serious damage. And then by the time when you get to, millimeters in size, there are 100 million pieces inferred in orbit. And this could cause just degradation of the space environment. So space is really, really big, but the actual kind of encounter areas of all these objects with each other is not that widely separated. So you traverse a lot of space every orbit. And so the interaction potential is actually quite high between objects. And as you get all of this material coming back in, the really big pieces then create these problems that we're seeing with casualty risks on the ground.
And just following up on the example that you gave about satellites, for someone who is less familiar, just how reliant is modern society on satellite technology and how so? And I know you talked a bit about the kind of ratio of active and non-active satellites, but do you think the volume of space technology is proportionate to our current use for it?
In terms of humanity's reliance on outer space, yeah, we are very reliant on outer space more than people realize. Outer space brings tremendous benefits to society. In a lot of the work that we do, where we're looking at, questioning how many satellites should we put up there and so forth, it's all within the context that satellites are incredibly important and we want to be able to continue to use them in the future. If we continue the pollution that we're seeing, we won't be able to do that as efficiently or effectively, or we could even completely, in some cases, we could screw it up so that we won't be able to use a space as we know it at this time, at least for a while. We use it for farming, we use it for navigation, climate research, search and rescue. Cospas SARSAT, headquartered in Montreal, was developed during the Cold War and was a collaboration that started between Canada, the United States, the Soviet Union, and France. And the legacy of that is now that there are satellites that are constantly looking for emergency locator transmitters that are active and then send signals and they can figure out where they are. And over 2,000 people per year their lives are saved as a result of this technology. And, so one, this was cooperation among adversarial states that developed during the Cold War and a time when we aren't thinking that some of the most extreme stresses that we've seen between states. So space is really a way of cultivating that. So space is also a place of cooperation, coordination with all the things that are happening in Ukraine right now. United States astronauts and Russian astronauts are going up and coming down from the ISS together. So a little separate from the satellites themselves, as we typically think of satellites, but I think that's another important point. Uh, Severe weather monitoring, early warning systems, treaty verification, such as fisheries, weapons, arms control. So these are all ways in which humanity uses space to great benefit, telecommunications, of course. And if you start interrupting that, it can create huge stress. And so, for example, there's such reliance on GPS or other types of area navigation type of infrastructure that we've been able to create high degrees of efficiency using it. It's not that we can't live without it, but it does create tremendous efficiencies. And so we've seen in places where GPS is getting blocked as a result of conflicts that there are civilian implications as a result of that, such as ambulances can't get to places as quickly. There are supply chain issues that start to occur. And so, like, our dependence is very, very high. But that leads to this question of all the ways that we're using it right now. Is that the best way that we could be using it? And how many satellites do we need? And actually, that's a question that we need to constantly ask ourselves. And there's no easy answer to that. So I can't give you a number. I can't say whether we're doing that or not. I can say that some of the proposed activities, or the proposed type of infrastructure putting up, cannot be long term sustainable, at least in the way that it is being proposed. And a lot of the things that are, or a number of things that are being proposed, simply shouldn't go up there. And, how do we, decide what can go up and what can't? A very simple example that I think a lot of people would be happy to push back on is space-based obtrusive advertising. So imagine that you have satellites that are arranged so that it could spell out, put that brand name in the sky, going across the sky as basically a set of very bright moving stars. So there are other types of things that are kind of somewhere in between that and what maybe people would be okay with. So one of them is artificial meteor showers. So for your wedding, for your concert, or whatever big event, there's a company, a Japanese company, and they have prototypes already in orbit, which will shoot basically pellets with different coatings at a specified location at a specified time to create an artificial meteor shower. There are companies that will launch CubeSats with symbolic human remains so that your loved one can be turned into a shooting star upon reentry. Basically, if you could think of a way of using space, other people are thinking of that way to use outer space, and not all of those really should be pursued. And you might ask, well, why? What's the big deal with that? Well, it comes down to all these other unintended consequences of doing these type of activities, such as casualty risks associated with re-entering material. Little CubeSats won't do it, but the rocket that put up the CubeSats could be a problem if not treated correctly. We're actually changing the chemistry of the upper atmosphere as a result of both rocket launches and re-entries. That ablation I mentioned is actually changing the chemistry of the upper atmosphere, and that's being measured. We're already starting to mess around with that in ways that we don't understand what that's going to do, but we know we're changing it. So it's that conversation of like, what can we do? What's the critical stuff that should be done? Going to the how much we actually need. This one is more straightforward. A lot of people will get behind the idea of providing internet services throughout the world. That sounds like a very good idea. To do it by completely blanketing Earth with so many satellites that you now start creating issues with effectively occupying regions of Earth's orbits. There are a lot of potential risks if something goes wrong. If it's managed, it's okay, but if it goes wrong, it can go wrong very quickly.
I just feel like I'm gonna have nightmares now of people wanting to send their loved ones' ashes into space. Cause that wasn't even a thing that I thought.
Yeah, so there's a planetary scientist, astronomer who has symbolic remains buried, well, not really buried, but on the moon. That's Shoemaker. And that created, as one might expect, with a lot of the discussions that are happening in society today that weren't happening, that created tension with the Navajo Nation, who saw that as an affront to kind of how they view the moon as a sacred place. And many other nations throughout the planet, indigenous or not, can look up and have different views of the moon. And there are some places where people say, well, it's okay to do this activity, and other places other groups of people who will say, no, it's not okay. And so one thing that happened recently is that this was brought up again because there was a commercial spacecraft going to the moon, and it was carrying then symbolic quantities of human remains. So these are like, cremants within like a little capsule. So it's just some, parts of some person's ashes. And they're putting it in there. And actually, after the Shoemaker incident, NASA told the Navajo Nation that, yeah, we will make sure that there's consultation before anything like that happens again. And then this occurred and there wasn't the consultation. And so it kind of public outcry as a result of this particular use. And, you know, with all the things that could be done on the moon, the cremants become very symbolic of the issues of how some people can say one thing is okay, another thing is not okay. There are issues such as strip mining the moon, potential appropriation of regions of the moon by a company or a state in order to mine it. These are like some huge questions, but some of those get kind of glossed over when you start talking about putting human remains on the moon. I think it really kind of focuses that question of what should we actually be doing with another world? And the moon is another world.
I'm just wondering, like, if, when the internet started happening and laws were very slow to come to kind of the repercussions of it, are there similar kind of delays with the law and space junk and kind of who gets to do what and where, or is that still not really a conversation yet?
Oh no, there's a lot of discussion about this, and you will hear a myth constantly repeated saying there are no laws in space, it's the Wild West and all this other stuff. And that's just absolutely not true. One of the things, though, that is happening is that the kind of changes that we're seeing are happening very rapidly, and kind of the interpretation of existing law and the policies that evolve from that are, being forced to try to move quickly. And there are places in which, such as, say, the United Nations, where that can take a long time to deal with. It doesn't necessarily, but it can. But we have actually 5 treaties that deal with outer space, and 4 of them are quite prominent. The Outer Space Treaty is the core, and it was written in 1967. And a lot of people point to that and use it to say, see, this is kind of this old piece of law that's no longer relevant. And actually, the Outer Space Treaty remains extremely relevant today. It has a bunch of rules and laws and ideas that many of which are vague but binding. And it's actually really important for that distinction because it sets forth basic expectations for states. And then states, according to what's happening and current practices, have to ensure that they are meeting then their obligations through both the purpose and the object of the treaty itself. And so that can evolve without actually having to sign a new treaty, which is actually quite important. And then there are 3 other treaties that came out of the Outer Space Treaty that basically clarify different articles in it. And as an example of that, there's liability for the space junk that we've been talking about. So if there is a accident on orbit as a result of somebody else's spacecraft or junk or debris, then there is an at fault regime. But if there is something that happens on the surface of Earth, then there is absolute liability, which means it's not fault based. So if it's on orbit, that creates this issue of saying that, well, is somebody at fault or not, right? And that creates this whole problem of attributing fault and so forth. But on the Earth, it doesn't matter if it was negligence or you did the absolute best that anyone could possibly do, and there was still an accident, is that absolute liability. And so if it's your piece of junk, if it's your thing that came in and re-entered and killed somebody or wreaked havoc in some way, then the state who owns that or the state in which the company who owns that is incorporated, they're the ones who are absolutely liable. Now, the problem with it is it's state to state. So, say it's a US piece of space junk and it hits a Canadian's house. The Canadian can't then just go sue the United States under the Liability Convention. Canada would actually have to file a claim under the Liability Convention. So, it is a bit more complicated. That doesn't prevent any individual citizen from pursuing a lawsuit on their own. It's just that convention isn't easy to wield for any given person. So these are kind of some of the complexities that we definitely end up seeing as a result of it. But in terms of whether you can put, 100,000 satellites in a single orbital shell, that is then being tested right now in terms of space law and how the rules of law get enacted.
You can just see Carol and I going through all the stages of grief as you speak. So if you see nervous laughing, I apologize.
Well, there's a lot to be concerned about. There's a lot of excitement about, the possibilities that are here too. And so I don't want that to be lost. I mean, we're having this problem because we are talking about, fundamentally being able to change the way we use outer space. We are talking about different ways we can use it and bring even more benefits to society. But as we do that, we have to understand that it's another environment that humanity is interacting. And where humanity is interacting in other environments, pollution has resulted. That pollution has had really bad consequences in many cases. And it's a matter of getting a handle on that pollution before we really harm our ability to operate or harm the environment itself. And so a lot of possibilities, but we just have to do this responsibly. And that's why we're having this discussion.
In one of your recent talks, you mentioned how a lot of us think that space is so big that our actions there do
Right.
not matter. Can you explain a bit more about why that kind of framing is problematic?
Yeah. I mean, this is just something that humanity does over and over again. And there's the pervasive belief that the atmosphere is just too big for humanity, to alter. We could do what we want. And of course, that turns out not to be true with greenhouse gases. With plastics in the ocean, you're looking at the ocean saying the ocean's so big we can do whatever we want to it. And that clearly is not true. Outer space is another place in which, this is happening to us, where we are having our own trash fall back and causing disruptions. We're seeing disruptions to airspace and having flights be diverted as a result of re-entering material. These are still big pieces of material, but that action is happening. We're seeing changes to the upper atmosphere already as a result of the reentries as well as the rocket launches themselves. And then once we start really operating on the moon, we're going to see the potential for changes there that are even more consequential than what have happened so far. At the moment, it's still been pretty small, but even with the limited use that we've had with the moon, there's over 180,000 kilograms of material up there from humanity on the moon that goes from a wide range of things. So we tend to have this view that what we do doesn't matter, except everyone has that view, and it quickly then kind of runs out of control. In space, returning to one of the earlier questions, I really want to impress upon the listeners that when you're talking about an object in orbit, yeah, so Earth is huge and space is also huge. An object will go about the Earth in about 90 minutes. And to be in orbit, it's sweeping out a huge volume of space for its size. And that's why the interaction potential of it and other objects is also so high. Going back, I mentioned the 10-centimeter issue. If you could get hit by something that's 10 centimeters in size, very roughly speaking, that's when you have catastrophic disruption. To really try to drive home this, if you have a hockey puck in orbit and it hits something at a typical orbital speed, energy, just from the kinetic energy that gets imparted in the object that hit, is similar to a few kilograms of TNT. So that's the type of energy that we're talking about that can get distributed into an object, create this disruption. It's not just the orbital environment and also kind of the forward and back reaction, like changing the atmosphere or changing the surface of the moon that becomes, a potential issue. We're changing the night sky. The sky is just absolutely full of satellites. And one of the reasons why most people don't realize that is because they've already lost the night sky. They've lost it because they live in a city and you can't see a dark sky unless you go out to a place that has very low light pollution. So these are all things that, are ways to see that type of impact that we are changing the environment and things to consider that, space is not so big that humanity can just ignore what it does. And what I really hope is that we understand that, we, being society, humanity, that we understand that before we have effectively a Valdez moment in outer space. So the Valdez oil spill in Alaska was this moment in which there was a huge resistance to having additional safeguards for oil tankers, such as double hulls and so forth, for a litany of reasons, but mainly pushback from operators who wanted to keep costs low. And as soon as you had that spill, that was enough. And there was a sudden change in the policy, which was a better policy, which helped to prevent oil spills going forward, not eliminate them by any means, but help to prevent them. And I hope we can do those basic precautions now before we have that Valdez moment in outer space. Because while we've had collisions between satellites, we have constant explosions. Batteries just explode, create debris. There's leftover fuel that occasionally explodes, creates debris. Unfortunately, states on occasion will blow up their own objects in outer space to demonstrate they can. They will shoot a missile at it, or they will have a killer satellite come next to one of their satellites and blow up. These are called anti satellite weapons, and that creates a tremendous amount of debris. And hopefully, we're moving past that, but there's no guarantee that we are.
I'm still stuck on the they can kill it just because they want to show that they can kill it. That's crazy.
So, one thing that's hard to appreciate is that just as capabilities to reach outer space were developed, side by side with it was military applications of space. And so, space is a domain where peace is central to its use and exploration. The moon, actually, under the Outer Space Treaty, is supposed to be used exclusively for peaceful purposes. But the history of access to space has been coming from rockets that were used to develop missiles to launch warheads at great distances, and that gave access to outer space. And putting objects into orbit and so forth became a demonstration of intercontinental ballistic missile capabilities. And developing that was similar to developing those type of objects. And then as you put something in space that you realize that could be useful in many different ways, one of those ways is to take pictures of maybe what your adversary is doing, then it became, from a military point of view, necessary to have counter space capabilities. And you'd be able to either prevent that picture from being taken, prevent transmission of information between satellite and ground stations, or in an extreme case, to be able to blow up that satellite. And so we've seen this kind of progress over time. It's still the case that outer space has largely been stabilizing, but there are no guarantees that that will continue in the future. So it requires everyone to work hard to make sure that it is stable and peaceful in the future.
Here I was scared about nuclear wars. So, on a brighter topic, how is your work at the Outer Space Institute kind of helping to create potential solutions or kind of being the hope pillar that we need in these scary times?
Well, some of the things that we try to do is, point out the risks, identify the risks that are associated with these activities so that at least we know what they are, draw attention to them so people can't ignore them. Once we have those, then we can start working on various solutions. As an example, we have these reentries that are creating problems. A good deal of the issues can be addressed, at least for the larger pieces, by requiring controlled reentries. So, one of the big problems with kind of the casualty risks with incoming debris is that it's completely uncontrolled. So, it can come down at any point kind of along its track of orbit. And, so, to give an appreciation for what's happening, Earth's atmosphere extends pretty far into the orbital environment. And as satellites are orbiting in kind of the lower orbit region, they feel drag as a result of the atmosphere and they slowly decay. So if they're left there without any thrusters, they will slowly decay and re enter the denser part of the atmosphere and then fall back to the surface of the Earth, break apart, ablate, and a combination of all of that. The problem is the number of uncontrolled reentries continues to rise, even though we're seeing more and more and more controlled reentry. So that's very positive. But just with the increasing use of outer space, we're still seeing the growth of uncontrolled reentries. One of the solutions is just to have that controlled reentry regime and make it really a rare incident when something comes back uncontrolled. There will be problems with many of the satellites because so many satellites do not have capabilities to have controlled reentries. And so that will then have to have a different type of solution. And this is something that we're working on where you have certain limits that you put down that are agreed upon internationally on how often you have these objects that are coming in uncontrollably. There are two parts to that. One of it, if something comes back uncontrollably, you have to make sure it demises in the atmosphere entirely so that it completely ablates. Now, that's actually a really hard problem. It's really hard to get that right because there are many kind of things that can go wrong in the process and try to limit how much is actually coming in because you want to try to ensure that you do not change the environment too much, at least, until we understand what the consequences of doing so are. Because at the moment, we know that it's possible that by changing these aerosols or adding new aerosols, that we could do things such as affect ozone. We can affect the climate system. All of that is quite possible, but we just don't know the extent. And so until we have that better understood, we have to have limits on the entries to work at least some large fraction of the time. It can't be perfect, but a large fraction of the time to be like, you know, at or below the visibility threshold of the human eye. And that's one for a cultural heritage. Then just for basic science, they might need to be a little bit dimmer because they are interfering with ground-based astronomy. So these are a couple different ways in which that's done.
Thank you so much. I guess our closing question for today is for the average person who is interested in this or is new to learning about all of the issues that you've laid out today, like what can folks do to stay engaged? How can they feel like their actions are contributing in some way to what can feel like a really big and scary problem?
Yeah. So, I mean, one is to certainly learn more about it. Take this as an invitation to learn more about it. The second thing is, what do you do with that knowledge? Well, you can engage with other people to make sure that others know about it. But then, you can contact your MLA and MP about it to talk with them about these issues. It is no longer in any way abstract to bring this up because, as an example, Saskatchewan now has multiple space junk debris finds. And why Saskatchewan? It's because there's a lot of open fields for farming, and a lot of farmers are very carefully going over their fields. Even if you just kind of search for some articles that are written by me and my dear colleague Samantha Lawler, where we talk about this, at least in the context of the Crew Dragon trunk reentry that spread potentially lethal debris across Saskatchewan, that will kind of start you down the path to finding out more about what's happening there. So it's not abstract, and you can talk with people about that so that there's a plan of how you can actually move forward because very few people actually know what to do when you find a piece of space junk. There's no clear policy for the average person of what to do. If you use internet services, that's okay. That's totally fine. They're really important. But if you have a provider, if you are using something like Starlink, if you are using one of the other providers, write them and let them know how important space sustainability is to you. They'll probably write back and say, yes, we also take it very seriously ourselves. But you could really emphasize that no, you need to take this very seriously. And so these are the types of things that you could do. There's one more thing, and that is on occasion, governments will have consultation. It may be your provincial government, it may be one of the divisions in the federal government that has a consultation that is very relevant to this question of reentries, satellites, light pollution, all of that. And you can, as an individual, respond to that and let them know your thoughts. And a final thing, if you are a writer, if you're a communicator, write an op-ed about it. Tell people what you've learned. Find a way to communicate what you've learned to a broader audience. It's not something that any individual is going to change. It's something that we are going to have to work on.
Great. Amazing. Thank you so much for your insight and your time. Really appreciate it.
Well, thank you for having me.
So if you're like me and you already have climate anxiety, now you can add space junk anxiety to the list of things of why the world is scary and why people do scary things with really cool technology. My favorite part of that conversation was learning about the fact that people want to have fake meteors for their wedding. Like, that's a thing that we can now do for people's weddings. I swear this is why we deserve nothing good.
Favorite part of the conversation, that was the most horrifying part of the conversation for me. But I think it just goes to show, like, there are no limits to how far people will go to do silly things that we don't really need. It, yeah, was shocking to me, but also kind of not. I feel like my favorite part of the conversation was when Erin talked about how, yes, this might feel crazy because it's in space, but also, like, none of these tactics are new. Like, invading a place that we shouldn't be in the first place and using really harmful methods. I think, like, knowing that it's kind of fits into a long history makes it in a way less scary because it's not completely revolutionary, but also hearing the ways that we can take part is always comforting for me. Like, we can raise our voice, we can talk about it, and, like, one person may not be able to fix it, but as a collective, we can hopefully inch things a little closer. I know that's, like, my textbook, like, optimism, and you're, like, shaking your head.
No, I like it. That's not where my brain went. But I do agree. And, as Aaron said, write to your MPs, your MLAs, if this is something that really freaks you out, as it should. And please, for the love of all good things, stop asking for fake meteors and your mother's, no, that might be too much. Your mother's dead ashes in space. I don't know. Just stop asking for these things. And please, if you're a brand doing marketing, I don't want to see your advertisement on my sky, on our sky. That's it.
Moral of the story, space is not a giant waste bin. So let's think a little bit more critically about how we interact with it.
And if you ruin our atmosphere, our aerosol, like we've already ruined our ocean, you'll be hearing from me. Thanks everyone for listening. Make sure you catch our next episode by subscribing or following our show on Spotify, Apple, or wherever you get your podcasts. And if you're feeling your feels, please drop us a review. You can find me on Blue Sky at Carol Eugene Park.
And me on Twitter at Jeevan K. Sanga. From Here Forward is an alumni UBC podcast produced by Podium Podcast Company.